Hello everyone. In this video, we will see few other examples to calculate time complexity. In previous video, we have studied how to calculate time complexity. So this is the algorithm to add two matrices. So here we are taking five parameters, that is A, B and C. These are arrays. So A is for first array, B is for second array, and the addition will be stored in C array. M and N are used for the number of rows and number of columns. So in algorithm, there are two for loops. First one is, that is I for loop, which starts from I equal to 1 till M. So this will be repeated M plus 1 times. Next for loop, that is J equal to 1, and it will continue till N. So this loop will execute starting from 1 to N. That means it will execute N plus 1 times. And because it is in I loop, so it will execute M in bracket N plus 1 times, that is Mn plus N times. And next, in J for loop, we are calculating addition of two matrices, that is C of ij equal to A of ij plus B of ij. So this loop will execute M into N times. So now we will take table and we will see the time complexity. So this is the table. So here first two lines, that is name of the algorithm and opening flower brackets, that will have 0 steps because we are not calculating anything in that two lines. Even the last one, that is closing flower bracket, here also we are not calculating anything. Next, that is for loop. So here we will consider that as one step. Then next, that is J loop. Here also we will consider that as one step. And third one, that is calculation part, that is C of ij equal to A of ij plus B of ij, that will be considered as one step. Now we will see how frequently these steps are executed. So first, that is for loop. This will be repeated starting from 1 to M. So this M is for true condition, and even it will execute for the false condition. So for true condition, M times that for loop will be executed plus 1. That means even for false condition, we are checking the condition. So this for loop will be repeated M plus 1 times. The next one, that is inner loop, J equal to 1 to N. So this particular loop will be executed again N plus 1 times, but because it is in J loop, so that's why it will be executed M in bracket N plus 1 times. So basically it will be executed Mn plus M times. And the third one, that is C of ij equal to A of ij plus B of ij. So this will be repeated M into N times because it is in two inside loops, that is in I loop there is another J loop, and in J loop there is calculation part, that is addition of two matrices. So this particular statement will be repeated M into N times. So now by multiplying SE into frequency, we will get total steps. So first two lines, that is will be 0. Next 1 into m plus 1, that will be m plus 1. Next 1 into m in bracket n plus 1, that will be mn plus m. And next, that is 1 into mn, that will be mn. So the total calculation will be 2mn plus 2m plus 1. So this will be our time complexity, that is number of steps required the algorithm. Now we will take one more example. So this is to print last Fibonacci number. So this is the algorithm. So here first we are taking one parameter, that is n value, and then we are checking the condition whether n is less than or equal to 1. So if this condition is true, then true block, that is write n, this statement will be executed and algorithm will stop because else part will not be executed. If n is less than or equal to 1, this condition is false, then else part will be executed. So in that, we are initializing two variables in same line, that is f2 equal to 0 and f1 equal to 1. Then we are executing one for loop which starts from I equal to 2 till n. So this particular loop will be executed n times, n minus 1 times for true condition and 1 time for false condition, because we are starting from value 2, not value 1. If we have written I equal to 1, then this loop will be executed n plus 1 times. So because we are starting from I equal to 2, it will be executed n times. Next, in for loop, we are executing actually 3 statements, fn equal to f1 plus f2. So this will be repeated n minus 1 times, means till condition is true. So condition will be true till n minus 1 times. And same in next line, there are 2 statements, that is f2 equal to f1 and f1 equal to fn. Actually here should be fn, not n. Next, after executing this loop, we are printing, that is write fn. So this will be executed 1 time and algorithm will stop. Now we will see how to calculate number of steps. So basically for this particular algorithm, there are 2 parts. That means we have to check for the value of n. Suppose the value of n is 0 or 1, then only true block will be executed. If the value is greater than 1, then else part will be executed. So this is the table. So in first block, we are trying to calculate how many steps will be there for each line. So for first 2 lines, because it is just a name and opening flower bracket, so first 2 lines will be, number of steps will be 0. Next, if condition, so we are executing that, so this will be considered as 1. Then write n, so this will be again considered as 1 step. Else is just a statement, so we are not calculating anything, so it will be 0. Again opening floor bracket of else is considered as 0. Next line, in same line we are initializing two values, that is f2 equal to 0 and f1 equal to 1. So here there are two steps in a single line, so that's why steps will be 2. Next, for loop there will be one statement. So in that for loop, fn equal to f1 plus f2. So this will be a one step. In next line again we are executing two statements in single line, that is f2 equal to f1 and f1 equal to fn. So there are two statements, so number of steps will be 2. Then for closing floor bracket of for loop, it will be 0. Next, write fn. So this is one step, so it will be executed. Next, there are two closing floor brackets, so it will be considered as 0. So now we will see for the two different values. So because there are two parts, one is if and second one is else part. So first we will check for the whether, suppose if the value is less than or equal to 1, means the value of n is suppose 0 or 1, then we will calculate how many steps are required for this algorithm. So suppose n is less than or equal to 1, so again first two line will be considered as 0. So these lines are not executing frequently. Next, we are checking for if condition. So if condition is true, that is this will be considered as one statement, because we are executing that statement only one time. So we have mentioned that n is less than or equal to 1, that means this condition is true. Then what we are doing, we are executing a write n statement. So write n will also take one step, that is it is executing only one time, so the frequency will be 1. So these are the two statements that will be executed one time. Then because if block is true and we have executed write statement, else part will be get skipped. So program, or you can say algorithm, will end here itself if n is less than 1. So that means we are executing only two statements and the frequency is also 1, because we are executing that statement only one time. So if n is less than or equal to 1, then total steps required, that will be 1 into 1, that is 1, and then for the write statement 1 into 1, that is 1. So total steps required for this particular algorithm is 2 if the value is less than or equal to 1. So this is the steps required if n is less than or equal to 1. Now we will check another part. Suppose if the value is greater than 1, that is the value of n is greater than 1, then how many steps are required, we will calculate. So first two lines, it will be considered as 0, because first is name and then opening floor bracket. Next, that is if condition. So here we are checking the condition. Even though the condition will become false, we are executing that statement, that is if n is less than or equal to 1. We are trying to find whether n is less than 1, which is false, but we are executing that statement, that means frequency will be 1. Next line, because condition is false, we are not executing write n statement, so frequency will remain 0. Then else, it will also considered as 0, because it is just executing that statement, we are not calculating anything. Next, opening floor bracket, it is considered as zero frequency. Next, because condition was false, we are executing else part. So in else part, the first line is f2 equal to 0 and f1 equal to 1. So this entire line we are executing only one time, even though there are two statements, but the entire line is executed one time. So frequency will be 1. Next statement is for loop. So this loop will be repeated starting from I equal to 2 till n. So that will be n minus 1, and then for the false condition there will be one repetition, that is frequency. So the total will be n times this for loop will be executed. So the frequency will be n. Next, for opening floor bracket, frequency will remain 0. Next, fn equal to f1 plus f2. So this for loop will be executed n minus 1 times when the condition is true. So this particular statement will be executed n minus 1 times. Even the next line, even though there are two statements, this entire line will be executed n minus 1 times. So after executing for loop, the next is closing floor bracket, so it will be considered as zero frequency. Next we are writing f of n, so it will be executed one time, so the frequency will be 1. And then last there are two closing floor brackets, so frequency will remain 0. Now we will calculate total steps, that is by multiplying SE into frequency. So this is for n is greater than 1. So third line, that is 1 into 1, it will be 1. Next 2 into 1, that is for f2 equal to 0 and f1 equal to 1. There are two statements and frequency is 1, so 2 into 1, that will be 2. Next for loop will be executed n times, n minus 1 times for true condition and 1 time for false condition. So n minus 1 plus 1, that will be n. So 1 into n will be n. So n times will be the total steps for this particular statement, that is for I equal to 2 till n. Next fn equal to f1 plus f2. So this will be executed n minus 1 times. So 1 into n minus 1, that will be n minus 1. Next is f2 equal to f1, and there is another statement, that is f1 equal to fn. So there are two statements and it will be executed n minus 1 times. So by multiplying it will be 2n minus 2. And the last step, that is write fn, this will be executed one time. So 1 into 1 will be 1. So now we will add all these steps. So 1 plus 2 plus n plus n minus 1 plus 2n minus 2 plus 1. So the answer will be 4n plus 1. So the total steps required by this algorithm is 4n plus 1 when the value of n is greater than 1. So if the value of n is less than or equal to 1, the steps required will be 2 steps, and when the value of n is greater than 1, then the steps required will be 4n plus 1.